plus 14. So we don't have distributive property. If we divide our equation, there's no like terms on our left, no like terms on our right. And so we're going to move all our variables to one side and all our constants to the other. And so I like to move always my smaller variable. So 2x is smaller than 5x. So I'm going to move over this 2x by subtracting 2x from both sides. So I have 3x plus 2 equals 14. Now I only have one variable, but I need to get all my constants on the other. So I'm going to minus 2. Now I get 3x equals 12. And then we need to solve, so divide by 3. X equals 4. However, don't forget to check your answer. So we're going to do 5 times 4, plugging it back in, plus 2. Does that equal 2 times 4 plus 14? 5 times 4 is 20, plus 2, 22. Does it equal 2 times 4 is 8, plus 14? Yes, it's 22. We're good to go. Our answer is x equals 4. Now, your job is to go ahead and try these problems on your own. Pause the video, give them a try, come back and see if you got them right. So notice if you gave these a try, you should have work that looks somewhat like mine. It's going to probably vary in a different way. Maybe you did 2 steps at once. Maybe you subtracted your constants first. But you should end up with the same answer no matter which way you solve. And so for this first one, you should get p equals 6. And for the second one, k should equal 4. Look over my solutions. Make sure it checks out with your solution. If not, try to find your error. Otherwise, come ask tomorrow. Next is our first application problem. And it says it takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours. But it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? And so what we need to do is we need to come up with an equation, define a variable, and solve. And so this one is asking how many web pages would he have to make it worthwhile. And so that's what's going to be our variable. We're going to say x equals the number of pages. And our next thing is to write an equation. We know that it takes 1.5 hours per page. So it takes 1.5 hours per page he makes to use what he currently has. If he uses new software, it only takes 1.2 hours per page, but it also takes 8 hours of training initially. So it's 1.25 hours per page, but he also has to factor in that 8 hours of training. So how many would he have to make in order to save time? So he wants to save time. Setting them equal to each other would give us the least amount of pages he would have to make. And so from here, we just have an equation, and it's rather a simple equation that we can solve. So if we subtract 1.25x from both sides, we end up with 0.25x equals 8. And I like to think of this, because I'm not using a calculator, as 1/4 x equals 8. And to solve, we have to multiply both sides by 4, and x equals 32. So that means that the designer would have to make at least 32 pages in order to make the software worthwhile. If he's going to make less pages, he might as well just use his old way, because then he won't have to do the training. Next, we're solving for the variable with variables on both sides of our equation and distributive property, which we learned about last week. And so in our steps to solve, the first thing we're always going to do is distributive property. If we see it, that's what we need to do first. So I'm going to end up with 10x minus 2 equals 3x plus 33. And now, even though we have variables on both sides, we still follow our steps. Put all the variables on one side, all our constants on the other. So I'm going to minus 3x from both sides. Remember, we have this line down the middle. And I'm going to switch colors, and I'm going to, so if I got rid of the 3x over here, I need to put all the constants over on that side. I'm going to add 2 to both sides right away also, and make it all in one step. And then I'm going to end up with 7x equals 35. Then we need to solve, and we'll get x equals 5. Now your job, like before, go ahead and try this one on your own. See what happens. And when I solve for q, I get q equals 25. And remember, you want to go back and check your solution. So you're going to do 3 times 25 minus 15. You're going to ask yourself, is that equal to 2 times 25 plus 5? You're going to see if it is true. And once you work it out, you should notice that, yes, it is true. Next, we just have more examples. They get a little harder each time. Here we have 2 sets of parentheses, which means we're going to do distributive property. Twice is all. So we're going to do it on our left-hand side to get 42 minus 14a. We're also going to do it on our right-hand side and get negative 15a plus 5. And then solve like before. Add 15 in this case to both sides. But you could move it the other way. It really doesn't matter. And I'm going to do subtracting 42 right away also. Cancel, cancel. And I get a equals negative 37, if I did my math right. So let's double check. 6 minus 2 times negative 37. Does that equal 5 times negative 3 times negative 37 plus 1? And if I do the math, yes, it does come out correct. Next, you have one to try on your own, so pause the video, give it a try, and come back and check. And if you solve, you should end up with y equals negative 3. When you plug it back in and check, it works out correctly. And this next one, the reason it's in here is because notice that we have parentheses, but all that's out front is a negative sign. Really, it's just subtracting. And so when you do your distributive property, remember that we have that one placeholder in front. I know we talked about it in class, but it's just a reminder. So I'm going to have 2r minus 5 plus r equals 13 plus 2r. Come on, my like terms. 3r minus 5 equals 13 plus 2r. Ooh, that's an r. And then what you're going to do, just like before, get variables on one side and get your constants on the other. And we're left with a nice r equals 18. Plug in your answer and double check. Go ahead and do the you try on your own. And if you tried out the problem and checked your answer, you should see that b equals 7. Our next is our final slide, and it's also another real-world example, and it's related to geometry, and these are always my favorite. And so it says that the perimeters of the triangles shown are equal. Find the side lengths of the triangle. Before we can even do that, we first have to say, what is perimeter, and how do we find it? And perimeter, if you forgot, is the sum of all sides. So what you do is you add up the lengths of each edge of your shape. So I know a lot of us have forgotten that, so that's a nice refresher. And then if it says the perimeters are equal, what we need to do is we need to take the perimeter of our first triangle and add it to the perimeter. Not add. If they're equal, what am I thinking? We're going to set it equal to the perimeter of the second triangle. And so if we just take the sum of all sides with this first triangle over here, I'm going to take 2x plus 4 plus 2x plus 3 plus 2x, and I'm going to set it equal to the perimeter of my other triangle, which is a 2x plus a 2x plus a 3x plus 1. And then remember, we have to combine our like terms. So here are some like terms. I have I have a 6x plus 7, and that's equaling a 2, 4, 5, 6, 7x plus 1. And now we're down to just solving with variables on both sides. Put all your variables on one side. So I'm going to subtract my 6x. And I'm left with 7 equals x plus 1. Get the variable alone by subtracting that 1, and I end up with x equals 6. So if we plug it in and check our answer, we have 2 times 6, which is 12, plus 4, 12, 13, 14, 15. We have 16 there. 12, 13, 14, 15, 12. If we add those all up, we get 28, 29, 38, 39, 40, 41, 42, 43 over here. And then on the other side, we have a 12 plus 37. Actually, not 37. It's late, getting tired, I must be. It's really 3 times 6 is 18, a 19, which gives us a grand total of 43 also. So we checked it, we're correct. X does equal 6.